welcome to another day in the life. This is year 5. Today it's gonna be a short day. I just gotta go in and feed my cells really quickly. I'm also gonna bring over some samples from the lab in Baltimore. I did some mouse experiments there. So that's where I do all my in vivo imaging experiments, where I examine blood vessels or cerebral blood flow using 2-photon microscopy. That setup is in Baltimore. And then I'm gonna drive down to College Park and proceed from there. So we'll do some mouse. We'll isolate some vessels and feed cells. It's a short day. You know, before I came out here, I was just doing some work from home. I had a few meetings. I met with one of my undergrads who's a computational student, so we were doing some computational work earlier in the day. And yeah, now we are off. We are off to College Park. Yeah.
So I'm here today, here to feed some cells, set up some experiments, and yeah, so I'm just show you what it's like.
So first things first, taking out some of my stem cell media, letting it warm up at room temp so that I can feed my cells without cold shocking them. Okay, so what I'm doing right now is I'm going to measure barrier function, because I am working with brain endothelial cells, and my plates have these transwall inserts. So these are used to model barriers. The idea is, at least in our case, because we're modeling the blood-brain barrier, the bottom of this, the median at the bottom, that's essentially represents the brain side of the barrier. So these would be the contents of essentially the CSF, the cerebrospinal fluid. And the median on the top essentially represents the blood. The cells are sitting on the bottom of this well. And once you put it in here, you essentially have two compartments. You have the top and the bottom, separated by the well insert. And that's how we model the barrier in vitro and cell culture. What I'll be doing right now is I'm measuring trans-endothelial electrical resistance, or TEER, which is essentially a measure for barrier integrity.
Alright, so the way this measurement works is that we stick an electrode into the well plate, and this electrode has 2 probes, and it will pass a current from one probe to the other. And what we measure here is how much of this electrical current or electrical signal is blocked by the cellular layer. The tighter the cellular layer is, the more resistance there is. Basically gives us a measurement for how intact that barrier is, which would then translate to giving us an idea of how tight and impermeable it is. Now, the reason this is so important is because brain endothelial cells are the core blocks of the blood-brain barrier, which is important for maintaining brain health, because it keeps out neurotoxic and inflammatory compounds that can be found in the blood away from the brain. And this barrier is formed from brain endothelial cells, which are the cells that I study, have tight junction proteins that basically connect adjacent cells together, and it seals off any space between the 2 cells. That's what allows these cells to form a barrier. Now, while this is great for maintaining brain health because it keeps out all the bad stuff, it's a problem when it comes to drug delivery, because it also keeps out potentially therapeutic compounds. And that's why this is such a big focus when you're studying or talking about neurological diseases like Alzheimer's and Parkinson's. The other aspect of this is that the blood-brain barrier can actually degrade in these diseases, which allow some of these toxic compounds to enter the brain. And so my project actually involves both of those contexts in another disease that I'm interested in, and that's what I'm studying today. I am trying to determine whether the disease model has a difference in barrier function compared to the control.
After I finished measuring TEER, I started taking samples for metabolite measurements. I'm specifically interested in the concentrating of metabolites in the top and bottom of these transwells. I'm trying to understand how metabolite transport and utilization changes in the disease model.
So, got to leave the lab a little early today, so I figured I'd make a night in the life video. So pretty much the first thing I do after leaving the lab is check my car and look for any parking tickets, just to make sure I didn't get
signalized for parking where I shouldn't be parking. It's actually an hour ahead because I'm too lazy to reset the clock for daylight savings. But anyway, I still got some time to get a workout in. I feel like my cutoff is usually like 3-ish. I feel like at that point it's a little too late. I might as well work out in the morning at that point. So it was nice to see a fellow creature of the night. Hey buddy, how you doing? It's good to see you again. How are the kids? How's the wife? Good talk. See you tomorrow. One of the best things about driving at this time is 95 is completely clear. There's no traffic whatsoever. Plus, I get to enjoy the perks of listening to conspiracy theories on the radio.
Of NASA, the White House, the U.S. government, the political establishment, the academic establishment, because this stuff's been sitting in our archives under human possession for 50 years.
I'm gonna take it kind of easy. It's my first day back in a long time.
So I like to work out at Just the Life Gym. It's a really neat gym that's open 24 hours from Monday through Friday. There's a studio area where I like to do some dynamic warm-ups, like jogging, Frankenstein stretches, hip flexor lunges to really get those hips opened up. Now for the actual lift, I like to start off leg day with some squats. Today I'm doing some pyramid sets where I'm working my way up from lighter weight to heavier weight. Like I said, it's my first day back after being sick, so I'm not going too heavy, just really trying to get a feel for the weights. I also like to incorporate more dynamic movements like Muay Thai kicks, single leg plyometrics, and really emphasizing that mobility, especially after a long day of sitting in the lab. Afterwards, it's time to hang out with the other late night gym bros, usually, but today this raccoon wasn't feeling it, so it was on to my next animal friend, which was my cat. And then together, we work on some feline military presses, which look easy, but trust me, these are a lot harder than they look. And honestly, I think this cat might need to be put on a diet. Speaking of diet, I like to finish my workouts with a protein shake, usually with some almond milk, hemp seeds, fruits, and of course protein powder. It's a delicious way to end my late night workouts. Afterwards, I try to get some work done, send out a few emails, work on some writing before I go to sleep, just put the mind to rest, but I can't focus. You know why? Because this cat has other ideas. Yeah, he thinks it's playtime. And not just any kind of playtime, he wants to play fetch. So we go up and down the stairs for like 30 minutes or so. And by this point, I'm tired. I'm exhausted. It's time to go to bed.
Or so I thought. There's still a lot of entertainment outside apparently. Bro. Okay, now it's time to go to sleep. So until next time, sweet dreams, good night, and sleep tight.